Today we're going to look at solving systems of equations, the second method, which is called Gaussian elimination. And what we're going to do is we're going to use elementary row operations to create an upper triangular matrix. That means, for example, all elements in the lower left corner are 0. Okay, so you're going to have something that looks like this, or this is the plan. Right, that's what you want to happen. You want to create this bottom corner of zeros. Right, and that means that everything is in the upper right triangular part of your matrix. Upper triangular. Right, so this here is your matrix, and this here is your column matrix of answers. Right, we just, in Gaussian elimination, we just write it a slightly different way to what we did when we were using normal matrices, but we'll see it's the same thing. Right, now, in order for it to work, you must do your operations, or your elementary row operations, in a specific order. Okay, the first thing you must do is use row 1 and row 2. Then you must use row 1 and row 3. And then finally you need to use row 2 and row 3. If we do it in that order, it always works. If we decide to deviate from this, it sometimes doesn't work. So row 1 and row 2, row 1 and row 3, row 2 and row 3. Example number 1. Now what I'm doing is I'm going to do the exact same example that we did for inverse matrices, which was the other method that we did for doing this, just to show you get the same thing. So solve 2x take away y plus z equals 5, and x take away 3y plus 2z equals 2, and 2x plus y plus 4z equals -3. So that's my system of equations that I've got there. Right, so what I've got to do is create a matrix for Gaussian elimination. Okay, so what I do is I create a matrix that looks like this, right, and I separate my answers from the rest of my matrix. Now I forget that x, y and z exist for the moment. So it's 5, 2, -3, that's my answers. And my coefficients are 0, -1, 1, 1, -3, 2, and 2, 1 and 4. Right. So that's my matrix set up in a Gaussian way. Right, now what I want to do is I want to make this element here, and this element here, these three things I want to make 0. Now the order we do that is we always try and make that one 0, then that one 0, and then lastly that one 0. It's always that one, and then that one. Right, so what we do is we call that row 1, row 2, and row 3. Right, so now it's just numeracy. Now, just like with the rest of matrices, it's easy to make mistakes. So the top row always stays the same. 2, -1, 1, 5. Right, because I don't want to change anything in row 1. Right, that row I just want to keep, but I want to make this 0. So what have I got to do to that and that to make 0? So if I do 2 times that, and I take away that, right, so 2 times that would be 2, take away that would be 0. Right, so I'm going to do that to everything in this row. So 2 times that, take away that is 0. 2 times that would be negative 6, take away that would be negative 5. 2 times that would be 4, take away 1 would be 3. And 2 multiplied that is 4, take away that would be negative 1. Okay. Again, row 1, row 2. Right. That's my new row 2, but it doesn't matter, it's now row 2 in this element. Right. Then what have I got to do to this and this to make this one 0? So if I just do R3, take away R1. Because 2 subtract 2 would be 0. And again, I do that same to everything in the row. So it's 0. 1, take away, that would be 2. 4, take away 1 would be 3. And 3, take away negative 8. That's my row 3. Right, so I'm very, very close now. Let's put that out of the way. I've got these two elements here is 0. Now the only element I've got to do is this one here. And I always do that with row 2 and row 3. Right? The first two rows are fine. Right, so I need to make somehow making that 0. So if I do 5 times that, take away 2 times, 5 times that plus 2 times that. So 5 R3 plus 2 R2. 5 times that would be 10 plus negative 10 would be 0, so that's right. So 0, 0. 15 plus 6 is 21. And negative 40 plus negative 2 is negative 42. So we're at. We've got the bottom left hand corner elements to be 0. Now, all we need to do is read off a row. So row 3, remember, that's x, that's y, that was z at the start. Right? So that's telling me that 0x plus 0y plus 21z is negative 42. So 0x plus 0y plus 21z equals negative 42. So that's obviously 21z equals negative 42. So z is negative 2. Row 2. So 0x take away 5y plus 3z equals negative 1. So negative 5y plus 3 times negative 2 equals 1. Because remember z is negative 2. So negative 5y take away 6 equals negative 1. So negative 5y equals, move that across, it becomes add, so it becomes 5. So y is negative 1. Then lastly, row number 1. Is 2x take away y plus z equals 5. So substitute those in. So 2x take away negative 1 plus negative 2 equals 5. So 2x plus 1 take away 2 equals 5. So 2x equals 6. So x is 3. There we go. Those are 3 answers. So x equals 3, y equals negative 1, z equals negative 2. There we go. Right, so we did elementary row operations. So we had to make the bottom three elements all 0. Right. Example 2. And obviously it can get more difficult because the answers can be fractions and all that kind of stuff. But I don't think it ever particularly gets that bad. Right, so example 2, so solve 2x plus 3y take away z equals -1, x take away 3y take away 2z equals 4, and 5x plus y plus 3z equals 4. Right, so that's your system of equations set up. So 2, 3, -1, 1, -3, -2, 5, 1, 3. The Gaussian matrix. So I just write it like that. Okay, so again, let's label our rows. Row 1, row 2, row 3. And remember, row 1 stays the same. Right now, I need to make this element 0, and remember, you always use R1 and R2 for the first bit. So I'm going to say 2R2 take away R1, because 2 lots of that take away 1 lot of that would be 0. So 2 lots of that, -6, -9, -4, -3, and 9. Okay, so the double negatives will cause issues, right? Now remember, I now need to make this bit 0, and remember I use R1 and R3. So I'm saying 2R3 take away 5R1. Right, that would be 10. Take away that. Yeah, cool. That is 0. 2 of that. Take away 5 of that. -13. 2 of that. -6. Sorry, 6. Take away 5 of that would be 11. And 2 of that is 8. Take away 5 of that. Well, that would add it on, so that would make that 13. So R1, R2, R3. Now, see, sometimes if you just do the first two moves, it may fluke it and you may get a 0 in there as well. If that happens, great. Right. I don't need to do anything else, but it's not 0, so I need to make it 0. So 2, 3, -1, -1. 0, -9, -3, 9. And so I need to make this one 0 right now. So see, if you get complicated numbers, just think, right, if I do 9 of that and 13 of that, then it will just do the same thing, and they're both the same sign, so it's got to be subtract. So 9R3 take away 13R2. 0, 0, calculate it. I'm doing that right. Make sure you press the right button. I hit add instead, and then that just gives me 0. There we go. So I've now got my bottom left hand corner to be all zeros, and that's all I'm looking for and that. Right, so now I just roll off each row. You don't need to worry about the X and Y and stuff, right? I was just doing that for example in the first one. So Z0. That's 0. So Y, it's just -1. Then row 1. So finally I just get that X is 1. So final answer, if you want, X equals 1, Y equals -1, Z equals 0. Now if you go to your booklet on matrices, then there are questions on Gaussian elimination, and I'll just get the page. Okay, so on page 68 of the matrices booklet, question number 4 to 6, and please try it because it will be assessed at some point, right? And you will need it at some point, whether it's just now or whether it's in uni, you will need to be able to do it.